so that question on the math Excel says something like -5 and 3 are the solutions. And you have to tell what the A, B, and C were for the original equation. So if -5 is a solution, that means you solved it and you got x equals -5, right? So if you're working backwards, if you brought that 5 back over, that means x plus 5 was equal to 0. So if 3 is a solution, that means you solved it and you got x equals 3. So if you brought that 3 back over, that means x minus 3 was equal to 0. Is everybody with me so far? So that means your quadratic, you had an x plus 5 times an x minus 3, and it equaled 0. So now if we FOIL, x times x is x squared. Negative 3x and positive 5x would be a positive 2x. 5 times -3 is -15. So in this quadratic, it's ax squared plus bx plus c. So my a is 1, my b is 2, and my c is -15. So that's how you do that last question. It gives you the two numbers. You have to work backwards and multiply your quadratic to get your coefficients. Does that make sense to everybody? All right. So you have that Math Excel that's due by 3 o'clock today. And then we were talking about we're trying to get ahead and finish this section today so that tomorrow would just be a work day. So get out those notes if you haven't already. Yesterday we talked about the process for completing the square, and we did one example. So I would like to do another one now. Let's say I gave you this one. Step 1 of completing the square says it has to be a 1x squared, and if it's not, we divide by that coefficient. So we have a 1x squared, we can skip that step. Step 2 says isolate the constant. So I keep my x squared and my minus 3x, but I'm going to add my 2 to the other side. Now we need to make a perfect square. We talked about how to do that yesterday, but it's the same every time. You take your middle number, divide it by 2, and square. I can't actually divide those and get a nice answer, so I'm just going to square. -3 times -3 is 9. 2 times 2 is 4. So I'm going to add 9 over 4 to each side. Okay, from here we try to factor. But we talked about how it's always a perfect square, so it's always going to be the same parenthesis twice. It'll always start with an x. The shortcut, before we squared it, what was my number? So it'll be x minus 3 over 2. Okay, 2 plus 9 over 4. So what does that give us? 4.25. I'll just keep it as a fraction, 17 over 4. So now we're trying to get x by itself, so to get rid of the square we add a square root, and when you do that you have to do plus and minus. So over here those cancel, so we get x minus 3 halves equals plus and minus. I can't do the square root of 17. What's the square root of 4? So then what's my final step to get x by itself? Add over that 3 over 2. So it's going to be 3 over 2 plus or minus radical 17 over 2. do a couple more of these. Any questions on this one?
This is complete the square.
Yes. So again, we're doing this because if you try to do box method on the original, there's nothing that multiplies to -2 and adds to -3. So box method fails. So this is an option that will work every time. All right. 9x squared minus 12x plus 9 equals 0. Again, this is one, if you tried box method, it doesn't work. So if I asked you to complete the square with this, first step to completing the square, it has to be a 1x squared. This time it is not. So the first thing I have to do is divide by 9. And you're doing that on each side, every single term. That gives me x squared. 12 over 9 would reduce to 4 over 3. 9 over 9 is 1, equals 0 divided by 9 is 0. Step 2 is isolate the constant. So I'm going to subtract over that 1. Okay, step 3. We have to take our middle term, which is -4/3, divide that by 2, and square. So -4/3 divided by 2 would be -2/3. If you square, -2 times -2 is 4. 3 times 3 is 9. So we add 4 over 9 to each side. All right. So at this point, we've made a perfect square, so it should factor into something squared. We always have the x. The easiest way to get that other number is just look. Before we squared it, we had -2/3, so it's an x minus 2/3. If it were a positive 2/3, it would be x plus 2/3 right there. -1 plus 4 over 9. Then to get rid of a square, we add square root. With that, we need plus and minus. So those cancel. So we have x minus 2/3 equals plus or minus the square root of -5, just be I radical 5, square root of 9 is 3. Final step to get x by itself would be
Adding 2/3.
So it's 2/3 plus and minus I radical 5 over 3. All right. I'm going to do one more of these. Any questions so far? Excuse me.
Where did you get the -2/3?
So the easiest way to think about it is it's the number you got when you took this middle term divided by 2. So we always do b divided by 2. When we got that, we had -2/3. And that will always be the same number that goes in your factored form, the number before you squared it.
Thank you.
You're welcome. Any others? Let's do What do we do first?
Divide by 3.
Don't worry if you're getting fractions. We can do all this stuff on our calculator if we need to. So 3x squared divided by 3 is x squared. 5x divided by 3, I'm just going to leave that as 5 over 3x. Minus 2 over 3, can't reduce. 0 divided by 3 is still 0. Now what?
Negative 2 over 3 should be this.
Bring over that constant. Now what?
And then take 5/3 to the second power.
Take your middle number, which is 5/3,
Divided by 2.
divide it by 2,
Square
and square. So if you're doing that on your calculator, put the 5/3 in parentheses, then divide it by 2. And I just usually keep it in terms of fractions, so that would be 5 over 6. If you square that, 5 squared is 25, 6 squared is 36. So we add 25 over 36 to each side. So then, this will always factor into an x plus or minus something squared. To get this number, just look, before we squared, what did we have?
5, 6.
So it would be x plus 5, 6 squared. Okay, over here, use your calculator to add those if you need to. 2/3 plus 25 over 36.
49 over 36.
You did plus 25 over 36?
You gotta put parentheses around both of them.
Yeah. 2 over 3 plus 25 over 36.
Yeah, 49 over
Okay.
36.
I don't know why I was thinking that was not. Oh, never mind. I know what I did. Okay, that's correct. Sorry, Bill. So now what? And with that, you need okay. So we get x plus 5 over 6 equals plus and minus. The square root of 49 is
7.
square root of 36.
6.
Then how do we finish it?
Subtract.
Do you guys notice anything about these? Yeah. Can you add and subtract these? Negative 5 over 6 plus 7 over 6 gives us what? Hmm?
Did calculate.
1/3. Negative 5, 6 minus 7 over 6. So my answers are 1/3 and -2. That means this original one, actually box method would have worked. We didn't catch that, but completing the square gives us the same answer. So completing the square works on any problem, whether or not it can factor nicely. Do we need more completing the square examples? The second piece we wanted to talk about, there is one other option that always works regardless of your equation and whether it's factored nicely or not, and that is the quadratic formula. So we wrote that down yesterday. I want to practice 1 or 2 examples using that. So let's say I gave you this one. In order to use the quadratic formula, it needs to be in the form ax squared plus bx plus c equals 0. So you have to get it equal to 0 first. So I will start out by adding over my 2. So then we can use the formula. What is my a value?
1.
And my b? And my c? So we wrote down this formula yesterday. X is the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So opposite of b, opposite of negative 4 is positive 4, plus or minus the square root of negative 4 squared minus 4 times 1 times 2 all over 2 times 1. From here, we just start simplifying. Under the square root, 4 squared is 6, negative 4 squared is positive 16. 4 times 1 times 2 is 8. Unlike in Algebra 2, I know a lot of times you just were able to give a decimal for your answer. We have talked about reducing radicals, so we are going to give exact answers. So 16 minus 8 is 8. What could you do here? So if we break down our 8 into the square root of 4 and the square root of 2, the square root of 4 is 2. Alright, so then 4 divided by 2 is 2. Plus or minus 2 radical 2 divided by 2. It's just square root of 2. So we get 2 plus or minus the square root of 2. Questions there? Why don't you guys try this one? And we have x equals, opposite of b would be 1, plus or minus the square root of b squared minus 4 times a times c all over 2a. Now, you might have set this up differently. You might have subtracted your 2x squared over. So you had a negative 2x squared on this side, and your a was negative 2, b is positive 1, and your c is negative 4. You will get the same answer. So it doesn't matter which one's positive or negative. You just have to have everything on one side. So then we have 1 plus or minus. Negative 1 squared is 1. Minus 4 times 2 is 8, times 4 is 32, all over 4. Everybody with me? Okay, so you get 1 plus or minus the square root of negative 31 over 4. At this point, if you have a negative under a radical, what do you have to do? Take out an I. We break these up, so it's 1 over 4 plus or minus I radical 31 over 4. Any questions on that one? Do we need another quadratic formula example? We'll do one more. Let's do one where we can simplify a little more at the end and talk about what to do there. So we need everything on one side. So what do we have to do?
Add over 5.
We have negative 3x squared minus 2x plus 5 equals 0. So then my a is negative 3, my b is negative 2, and my c is positive 5. All right, so opposite of b be a positive 2 plus or minus the square root of b squared minus 4 times a times c all over 2a. From here, we start simplifying. Negative 2 squared is positive 4. Negative 4 times negative 3 is 12, times 5 is 60 over negative 6. You sure?
You divide everything by from the beginning part.
I just multiplied those two together to get my negative 6. But yeah, it's all over 2 times a. Okay. From here, what do you notice about this radical?
I think it's in 5, 8.
Yeah, square root of 64 is 8. I don't want you to leave your answer like this. We can finish this. That means we have 2 answers. 2 plus 8 divided by negative 6 and 2 minus 8 divided by negative 6. 2 plus 8 is 10 divided by negative 6 would reduce to negative 5 over 3. 2 minus 8 is negative 6 divided by negative 6 is positive 1. So if you have like terms at the end, then you can go ahead and finish it. Is that one okay? One last piece that we need to talk about. When we are looking at these, sometimes we get 2 different answers. Sometimes we get real numbers, sometimes we get imaginary numbers. It's even possible that we might just get the same answer twice. And all of that has to do with the discriminant. Which is b squared minus 4ac. So this is the final piece in this section that we have to talk about. All right. This comes from the quadratic formula. If you think about this formula we've been using, there's actually a couple pieces here. Have you seen negative b over 2a before? Yeah, we used that when we were graphing quadratics. That gave us the vertex. The discriminant is b squared minus 4ac, which is that thing under the radical. So the discriminant itself doesn't include the radical, it's just those numbers. Now, what happens with that is it predicts the type of solutions we're going to have. If b squared minus 4ac, so if your discriminant is greater than 0, then what that means is you will have plus or minus the square root of some number. So we get 2 real solutions. Okay. If that discriminant equals 0, then you would have, let's say, we set up our quadratic and we had x equals negative 3 plus or minus the square root of 0 divided by 1. What is the square root of 0? 0. So we're left with negative 3 over 1, which is negative 3. If that discriminant is 0, you just get 1 real solution. it'll actually have a multiplicity of 2. We talked about multiplicities yesterday, so that's just like a repeated solution. But if your discriminant is less than 0, if it's a negative, what does that tell us? What kind of solution is it if you have a negative under a radical? This one we had a negative under a radical and we got imaginary. So if it's negative, you get 2 imaginary solutions. Alright, so the last thing we're going to do is just look at an example of this, and then I'm done. On the Math Excel, it will say, it'll be like part A, find the discriminant, part B, describe the solutions. And it'll be like a multiple choice for that part B. So here, if I just care how many solutions, I don't actually need the solutions. You could certainly do the entire quadratic formula, but I'm not asking you to solve it. So all I really need is the discriminant, which is my b squared minus 4ac. So my b is negative 5 squared minus 4 times a, which is 3, times c, which is 1. So we get 25 minus 12. So my discriminant is 13. That is a positive number. So what does that tell us? Mm-hmm. B. What do I need to do before I can find the discriminant on this one?
Get 1/2 to the side.
Mm-hmm.
Same side.
So we have 3/4 s squared minus 1/4 s minus 1/2 equals 0. So my b is negative 1/4 squared minus 4 times 3/4 times negative 1/2. Okay, don't get hung up on the fractions if you need to. You could just put this entire thing in your calculator. Just put it in exactly as written. And we get 25 over 16. So what does that tell us?
Two real solutions.
Mm-hmm. Do we need to do more of these? If you got a negative 25 over 16 there, what would that have told us? 2 imaginary solutions. Okay. So, I'm done with these sections. There are 2 Math Excel assignments posted. One of them says section 3.3 day 2 and one says 3.3 day 3. The first one I think is 5 questions. The second one is like 8 maybe. So they're not very long. I am not doing anything else tomorrow. So we have some time now, but you also have the class period.